So, hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 205 and in this video I have to correct my big mistake from last video. What I did there is I tried to convert this code to C++ and we did this, right? At least I did it too, but wrong. I made here in this code a big mistake, and if you found this mistake in my last video, that's very good. That means you understand this code and pointer already better than me, and your tracking of pointer is very good. And if you don't found it, no problem. I made the mistake, so blame all on me. And you can still pause now the video and try to find it as a challenge. I updated my last video, the description I wrote in the description. I make a big mistake. There was a leak and you should challenge yourself and try to find the mistake which I made in this code explanation. The explanation itself is not bad, but there is one place where I made so a big mistake that it caused a big memory leak. So my exploit code here, what you see here, which is my solution, caused a super big memory leak, which you should avoid at all time normally. And you see, yes, I made the mistake which you should not make in programming. So try to challenge yourself if you want. Pause the video and see if you can find it. But I give you some hints because you don't have to go through all. Some hints that it makes easier to find the mistake. First of all, you can see this line here. This was before here, right? That was from yesterday. You can see I have to get it up. I need it now here on top. Or before we call this add function here, right? This is a hint. And my second hint is now, because this one is here, I can change in my code, which I have here, just one word and it works, right? I need just change here one word and it will work. And I give you my third hint. Let's count the pointers again, right? Yesterday we counted the pointers and actually there is one pointer which we missed, or which I missed to show you, and that is actually causing the big problem. Let's count the pointers as a repeat because this is anyway a pointer training and tracking the pointers. Here is our picture and let's go through this code here again. I will not show the arrow pointer. I will just show the pointers which we created yesterday, so that you try to find the pointer which is missing, and then you know anyway my problem here. So let's count again. We started here with this. We started actually here. And the first pointer was this one here, right? This is the first line. Okay, I showed you this. This is my, and this pointer here was called head. All right, we created this head pointer here. And I said, okay, this is pointing to null. That's okay. And it was called head. All right. Then we go here to the function. Careful, this one is just a return. It's a pointer, but a return value, right? This is not, that counts not as a pointer for us. But yeah, it is a pointer in a way as a return value pointer, but let's say this is not the arrow, right? Because here, this one, the return value of this oops, this is this one here. The return value here and the return value here, they are pointers too, right? Because return pointers. But these are, let's say, these are special function return values. This we count not as a pointer right now, but you can count them as a pointer too if you want. We will talk about this later more in detail when we go there. But this is not the problem. This is just the return value, and the return value is just a pointer which we can assign. So Yes, they are pointers because you say the return value is a pointers normally, but yeah, we keep them differently. Function return values is not. All right, let's continue. So I went then here in. So this one is a function return value pointer. This one we don't count. They are pointers too, but we don't count them. And let's go here. Then I showed you, okay, this is our values, parameters, which we get in, because here I call them. You can see I use here the score list, this 12. I showed you this one. And then interesting is here I showed you the pointers here, right? We created this temp pointer. I think it was the color. This one here was orange. And again, null. I called them temp. And then we created this iterator pointer. I think that was this color. I called them iterate, iter or something like that. And this is pointing at start. Also null, you can see it here. And then we created another pointer, which is a function. Again, we count this return value not as a pointer here. It is a pointer, but we don't count it. And we go here in this function body. And this function body is creating a pointer. We can see this tk and tk. Oops, no, let's call this one. This tk I called tk actually for temp node. And this one is not null. I said this one is creating our node here, and this one is also allocating our memory. That's very important here. So this was by the creating a default node, not this value here, default node. And very important, this default node creates another pointer. This node itself creates another pointer. I showed you this yesterday too. That was this red pointer, which is pointing to null, right? So I think these are the pointers which I showed you yesterday. And when we continue, that was here. So, and the other places here, they are just using these pointers which we create. You can see temp is accessing, then head is accessing, assigning, and we are creating no more pointers here down. At least we think so, right? So you can stop if you want again and try to find one more pointer which I missed and caused a big problem. So here, if you want, you can try to challenge you again. Try to pause the video, look here if you find one more pointer. I missed here one more pointer, and this missed, and if you find this missing pointer, then you can solve this problem here why I messed up here big. So you can pause it, and now I solve it. Where is this missing pointer? Actually, yes. Here, when we go down, I use a call, right? And I take this score list, this is here, as an argument, which is here, right? Here comes to here, with this pointer comes to here. And I explained you this anyhow, what I did later. In my explanation yesterday, I said this head here is moving later. When we go here down, you can see this head here in my code is pointing to temp, and temp was creating this here, this one assigned the values. So temp was moved. Let me show you this fast again. So this temp here moves from here to here, right? That was right. Then this temp here assigning this value, which means create 12 here. And this, we can see this here in this line, that was right. And then I said here with this first if state here that this head, which is this one here, which comes from our call, right? I showed you that this head is assigned to temp, right? So this head, this one here, is assigned to temp. Temp moved from here to here. With other words, I showed you yesterday, this one is moving here to the same place. It's pointing to the same place, right? And now I solved this problem. Actually, that is not right. This one is a mistake. So if you want, try to pause again the video and think about why this one is a mistake. And this green line here is this first if here. If you want, try to challenge you again. Pause the video and see why this is a mistake. Why is this a mistake? I mean, it's not really a mistake when you watch this line, but the mistake is, I solve it now. The mistake is this pointer head here is actually not moving here. But this assignment here, let's read this line here again, but wait a minute. Yes, the head is moving there, right? And when we read this line here, head is moving from here to here. The problem is this head null pointer is here, right? And it was assigned here, right? The problem is this here, this head here, and this one here are two different pointers. Which means what happens in real is when we go here, dive in, after I called here this function here, this add list here is creating this here, this head as a pointer itself. So head is this one here. And this one is our, how many pointers we have already? 1, 2, 4, 1, 2, 3, 4, 5 pointers, and this is our 6th pointer, the missing pointer. This one was here created new. And this one is a copy. You can see this pointer here is a copy. But wait a minute, when this is if this is a copy, how we know that this was a null PTR here? I mean, that is a valid question, right? Because this one here, this copy, checks this pointer here outside. Where is that here? This pointer here, this copy in this line here checks, no, not here, sorry, here checks if the argument which we passed, and we passed this one in here, if this is the null PTR here. So how is this possible? Very easy, because this head is created at this place, but this head here is pointing to the same place like here, which means it is created here, but it's pointing now, let's see, with the argument coming in, it is now going here. So the head is here actually, right? Can you see this? This again, very bad explained, but this head, and this one is just created here from here. This is a little bit complicated, but I hope you can see it. This one is created new. They are just pointing now to the same place, because I use here, oops, not here, we can see I use this value here as an argument. Argument means this head is now pointing to the same place like this one here. So, and if you want, you can try to pause the video again. And now, with this knowledge here, try to fix it if you think you can fix it now. Because, like I said, now with this knowledge, there is only one line which you have to fix, and this will work. This will work when you fix just one line, actually one word, not even one line, one word. And yes, you probably guessed it, I solved it now. It is this place here, this word head. So what we have to do here, it's not so easy to see perhaps so instantly, because this head here is used. We can see we have to go here. So here again, let's go here fast. We go create again this this temp node, this is this one, then the iterator, yes, we create this one, and then we create this tn from yesterday. So I don't repeat all that because we talked all about this in my last video. And then we assign this value, and then this all happens. So this temp here is going to this one that was in create node here, that's okay. But then we come to this head here, this if head, and here we check head equal null ptr. And this one here is actually absolute okay. Why is this okay again? Because this head is checking if you are null ptr. They are pointing both to the same place, right? Because this one is created now here, and this comes from here assigned. So which means this one is pointing to the same place where this one is pointing, and that's why it is null ptr, both pointing to null. This is this place, and then this head here, and now comes the mistake. I took this head here, which is this one, which is this one here. I took this one here, and I assigned it to temp. And temp is what? Temp is this, you can see this green thing what I made here, right? This was the first, this head here, the other one. The green thing was this assignment to temp here. Actually, the green one stays here to null at this point because this is not the same head, and this one is not the same. This one is a created new pointer here. This green stays null. This head here, which I created here, is assigned to temp, and temp was here assigned. So we have it here, right? So the temp is here. The green one is never here. This green one never happened. And I showed you yesterday, this one is assigned to this place. This is not true. This was never comes true. And with that said, so what happens in the next step is, when we go here a little bit further, you can see, and then we can skip because it was the if clause. We used here the first part, and the else will not execute at all, and we can skip this whole thing here. And important is now what we learned yesterday, and also in the last video. Here, the scope ends. And what happens if the scope ends? We learned this, I explained this in the last video. All the variables which was created are destroyed, right? So let's see what is destroyed here again. So, like I showed you this yesterday, the null pointer is not destroyed. This one, this head, this green one is not destroyed because it is not in the scope here, right? This one will be destroyed when the program terminates because it's in global space. So this stays till the program terminates, at least for in this script. So this green one will be not destroyed. Then our temp is created in this here. Yes, this temp here will destroy it here. Let's destroy it now. All right, you get, oh, where is that? You get destroyed. Temp is destroyed. Then our iterator pointer, we used it not, but later we will use it, but still get destroyed at the end of this scope here, right? We learned this, Control Z. We learned this. And then we can go on. This tn was already destroyed. I mean, when we call here this function, it is here, and this tn was destroyed after this one here. But we know that before it's destroyed here, it assigned the value to our temp. So this one is working, but it was destroyed in this scope here. All right, so this one is also destroyed. So, and when we watch now here, which is not this, and actually there is one more destroyed here. What is here destroyed? Look, this head which I created now, that was the new one. Here, this copy, this new created node here as a parameter was here assigned to our head, was here assigned here, and this one is destroyed too. which means, very important, now comes the Big Bang. The Big Bang is this here is a new node, a new node, and new means we have to manage this, right? With the keyword new created node, this one. And all pointers to this place, all access pointers are destroyed. And this green one was my mistake, was never assigned to this place because I accidentally misused this head here. And I thought this head was this green. Can see it? Which means yesterday I created early memory leaks. I created first this one. It created this node here. All access points get destroyed. And we have our first memory leak. Then, with my second call, I did the same thing again. With other words, this same thing what you see here happens again. It created again this new node here. Again with a default. And all the things here, you know it. And then all access points to this one gets destroyed, which means we have again no access to this new, right? And again with the last one too. That was the big mistake which I made in my last video, and I hope you see this now. This was, and if you already noticed this one, very good, then you are already a very good programmer. If not, don't worry, we are starters. And you see this stupid instructor who is me may explain to you something big wrong, and that should be not possible. But yeah, don't worry, in future we will anyway learn better ways to handle this one here. But we are not finished. Let's we found now the problem here. So we found now this head here is the problem. So with this information, if you have not solved this problem here, try to fix this. It is just one line which you have to change, one word which you have to change, and this one will work. All right. So what is where is this one word? Actually, I solve it now. It is this head here. This one here. This temp is okay. We need this. This temp, you can see this temp is creating here, creates this new node, walks to this place and is here. But this temp must assign it to a head, but not to this head here, which is created here as a parameter. This head here, we need assign this temp, and this is only at start. We do it one time because this is assigning this value only one time to this score list here outside, which means I just have to change this word score list, and this one solve it. And why? What I did here is this score list is my green head, and this green is now assigned to temp. And this step here, this green will happens with this one here one time. And after this one time, it will not happen again. And the reason for that is it will be never null PTR. This head will be never null PTR. It will has all time. Yes, it will all time find there a value, and this will work. So, and do you understand this? I hope you have made a better conversion than my code here. That was not good, like we can see, but now we can start this program and this will work. You can see this is printing also the values out, and this time all other things work like expected. This program, after it terminates, it will release all the memory because this head here, this green one, or in my case, this access point will only destroyed after this program is terminates. And when it terminates, all the memory goes back to the operating system. We talked about it. Normally you need the word delayed. In this case, you don't need the word delayed because the whole program terminates. But in general, just remember, when you use this word new, all time in combination with the word delayed in general. All right, this was the problem. And you can see, yeah, that caused that was my problem probably. But here are fast, I want to show you one more thing here fast, which is just a print function. So let's do at least a print function. And the print function is very simple. You can see it. I just created a void function. I called it print list. Let's make it here perhaps print list and change this one here to print list. Print list, okay. And you can see we get just one node in it. It's again a pointer, and this pointer is our start node. In my case, I called it score list, and the reason for that is, yeah, I make here scores later. I wanted to see if I can make this one. This one are just the numbers, but later I want to use this scores, and let's use our scores now. That was just to understand how a linked list works as an example here, but our goal is still in this exercise, right, to make our, yes, this linked list here. And let's see if we can do our numbers here. Let's see, I have here, better is I just copy this one here and then I type this one here down, this paste in, and let's see if I have the numbers right. So first 63, 50, oops, 50 and 10, and let's copy one line and see if this all is working. Perhaps it's not working, who knows. And that was again bad. I missed 30. Okay, let's put here 30, and let's delete this one here. It's no more needed. Okay, and let's see, the numbers looks good. So my score list here looks nice. Only not in the right order, but I mean in the right order, but not it goes not down. And here the print list is very simple. You can see I created a one while loop, and I checked as long as this node, which is our, for example, our head in our diagram, right? This head, it's the early access point. As long this one is not the null parameter, which means which means there is something which we can print out, which means we have here a node which has values, then you should print out the number and then go to the next node here. All right, that is, I hope, not too difficult after we discussed this kind of stuff. This kind of little code should be easier to understand. And we have already talked about while loop already, so we know this one probably. So, okay, I think this time, I hope it's right. And if it's again wrong, please write something in the comments. And with that, I think I stop this video, and like all times, if you have any questions, suggestions, write in the comment. And we see us in the next video. Bye, good luck, and like all time, have fun and never give up.